uncovered positive and negative ions is called the depletion region due to the depletion of free carriers in the region. Due to the presence of these positive and negative ions, a static electric field called as barrier potential is created across the junction. It is called as barrier potential because it acts as a barrier and opposes the further migration of holes and electrons across the junction. Now, we connect link to the ends of each material. We made the basic PN junction diode. Now, we connect positive terminal of the voltage source to the lid connected to P-type side. And we connect negative terminal of the voltage source to the lid connected to N-type side. In this condition, diode is said to be in forward bias condition. We already told that there is a barrier potential across the junction. This barrier potential acts in the opposite of the forward applied voltage. So, there is no forward current through the diode unless the magnitude of the applied voltage becomes more than that of barrier potential. This voltage we refer as forward biased voltage. For silicon, forward biased voltage is 0.7 volts. For germanium, forward biased voltage is 0.3 volts. If we apply more forward voltage than forward biased voltage of the diode behaves as closed switch. Now it gives rise to an uncontrolled forward current through the diode. There is no more voltage dropping across the diode beyond this forward biased voltage. We can only limit the current by connecting external resistances series with the diode. Now, we connect negative terminal of the voltage source to the lid connected to P-type side. And we connect positive terminal of the voltage source to the lid connected to N-type side. In this condition, diode is said to be in reverse biased condition. Due to attraction of positive potential, the free electrons in N-type region go away from the junction. Due to attraction of negative potential, the holes in P-type region go away from the junction. This makes the depletion layer of the junction wider with increasing reverse biased voltage. In this situation, the current does not flow through the diode. This is because free electrons in N-type region and holes in P-type region cannot cross this wide depletion region due to electrostatic force of the applied reverse voltage. As we told earlier, there are always some thermally generated holes in N-type semiconductor and free electrons in P-type semiconductor. We call these charge carriers as minority charge carriers. These minority charge carriers also present in depletion region. Due to electrostatic force of applied reverse biased voltage, these minority carriers will smoothly flow through the diode, because the polarity of reverse biased barrier potential does not oppose the flow of holes from N-type to P-type region, and free electrons from P-type to the N-type region. As the number of minority carriers is very few, a tiny current flows from N-type end to P-type end in the diode. This current is called reverse saturation current.